Welcome back, everybody. Today we're going to talk about K nearest neighbor, or KNN. And really the best way to explain this is to give a visual representation of what this looks like. So you can see this cluster of data points here on the graph. And what happens if I try and sort of confine those? Or what about if I try to make the group even smaller? Okay, and if we try to look at this in terms of comparing it to our neighbor points, okay, so the points in the small circle in the middle don't have really other neighbors that are very different from they are. But the ones on the outer circle, there's neighbors, but there are differences there. And what we're going to talk about is really, what is K nearest neighbor? Why do we use it? And how do we choose the K in KNN? And really, the last thing I want to talk about before we get into a coding example is, how does the KNN algorithm really work? And as you'll see, it's quite simple. The beauty is that the software does a lot of this heavy lifting for us. Okay, and as always, we build a model that can predict the future from the past. Okay, and this is still basically the same sort of algorithm that we've been following throughout the video series. So how do I tell the difference between two similar objects? Okay, and we've kind of done this with other algorithms in the past as well. But, really, like everything else we've done, we use past labeled data. Okay, so we've got this apple in cherries. Okay, so let's look at this example here on a grid. Okay, I've got cherries on one side, I've got apples on the other side. Begin. And with this, I have two different features that I can plot on my graph. I've got the joining stem, and I've got the size of the fruit. These are just two features that I've kind of randomly picked here. And now, what about this? I've got this sort of unknown thing, and clearly you can tell that it's going to end up being a cherry, right? But because of the similar features of the cherry, we can use KNN to classify it as a cherry. Okay, now focus on the features. Okay, don't focus on what it actually looks like. Okay, because it does make a difference. So when we're talking about K nearest neighbors, it's very similar to what we have done in the past, right? We have data that comes in, we go through our KNN, and then, hopefully we can predict the proper output. That's nothing new that we've done in the past. What's different is the way we're using the KNN algorithm. Okay, and you're gonna see when we get to the coding, how similar this really is to the other things, but it's just the KNN piece that really makes the big difference. Okay, so what is KNN? Okay, it classifies a data point based on how its nearest neighbors are classified. Okay, so it's nearest neighbors. So if we look at this graph again, right, and I put a circle on this graph, what this is really ultimately going to tell me is a yes or no. Okay, if I'm trying to make a prediction of a new data point, it's really going to say, is it or is it not something? Okay, so while I'm using classifications to input into my KNN, we've also got this phenomenon of the yes or no. So just bear with me. Okay, and with this yes or no, we can expand this and say, well, based on a similarity measure. Okay, so what's the similarity measure? So let's go and have a look at this. Okay, so I've got my graph here, right? And how do I know which KNN that I should be choosing? Okay, so K in KNN is from feature similarity. Okay, similar features to the one that I'm trying to examine. And you can see here in the middle, I've got the white dot. That's my unknown that I'm trying to predict. Okay, so K in KNN is a parameter that refers to the number of nearest neighbors, which uses majority voting. So very, very quickly, if you were to look at the white dot in the center, what would you just intuitively predict is the output for that white dot? So if I put this circle around here, okay, and then I say k equals 5. Okay, what you could really see is, based on this majority voting, that 3 out of 5 neighbors are red. So therefore, our point must be red. Okay, so that's how we predict it. Now, when choosing the right k, this process is called parameter tuning. Okay, and we'll look at this a little bit more. And this process actually leads to better accuracy. So this is a little bit important here. Okay, so when we want to choose k, but what about choosing the right k? So if we look at this sample again, and I have k equals 5, it says that 3 out of my 5 are red. Okay, but what about now I say k equals 9? Okay, 9 out of 14 are green. Okay, and pay attention to the fact that I'm using odd numbers, okay, because that's important. So if I choose a k that's too high, I get too long of a process time. Okay, it takes a long time to do all the calculation. It becomes computationally very heavy. Okay, but if I choose a k that's too low, then it kind of gets a little bit too noisy. Like I lose a lot of accuracy here. So for our options for choosing the right k, we really can keep this nice and simple. And that's really a good thing about this algorithm. So the first thing that we do is that we square n, where n is the total number of data points. Okay, and I'm going to actually show you an example of this. And this is where I wanted to say about keep the k value as an odd number. Okay, and this actually helps break a tie. Okay, so if you're looking, we talked about this majority. It's never good to have an even number of voters, because then there's no way to break the tie. So this is why we try to do it in multiples of odd numbers. Okay, so the question then becomes, well, when do we use KNN? What are scenarios where we would want to use that? For one, we know that we've got past labeled data. So this suggests strongly, or it actually explicitly says, that this is a supervised learning algorithm, okay, because you're using past labeled data. Okay, and the next thing is we look at this chart and we're talking about noise. Okay, so you can see here on this classification that I've got actually noise in my classification column. Okay, so when our data is noise free, it's very good for us. And you can see in this particular case, we've got a lot of noise in the classification output. Okay, we want yes or no, or we just want to classify something as either underweight or normal. But here you can see that 100 or 50 or hello world, like that's noisy data that we don't want to use inside this particular algorithm. And then really the last condition is that we're not going to have a gigantic data set. Okay, when our data set's going to be relatively small, anything maybe under a gigabyte of data, something very small, this is really kind of an appropriate thing. Now, I should say that I've used this before, KNN, in computer vision as well. Okay, so KNN is one of those things that you may see come up in a computer vision algorithm, but it's sort of outside the scope of this particular video. Okay, so how does the KNN algorithm work? Okay, so if you look at this chart and you're seeing I've got two features, I've got height and weight. Okay, and I'm trying to classify either underweight or normal weight. Okay, so underweight or normal. And I've got my sample data point that I'm trying to predict. Okay, I look at this and I say, is this going to be underweight or is this going to be normal? Now, the way we do this is with the Euclidean distance formula. Okay, and we use this to find the distance between 2 points in the plane with coordinates x, y, and ab. Okay, so if you look at it this way, I've got x and y, and I've got a and b. And this is all just go back to high school math, okay? And here is the Euclidean distance formula. So it's x minus a squared plus y minus b squared and square root. Okay, so very, very simple formula. So what does this look like in a practical term, right? So you can see here, I've got my white dot in the middle, and I want to do this calculation. So the first thing is I'm going to calculate D1. What is the distance from my unknown data point to a known data point? Okay, so I'm taking the features that I have, which is the height and the weight, and I'm plugging them into this Euclidean distance formula. Okay, and it's giving me this output of 6.7. Okay, so then I could do the next one. I've got D2, I'm comparing that. This gives me 13. And again, I've got D3, and I think you can see where this is going, right? We just continue to calculate for all of them. Now, I'm not going to have to write code to do all of these things for me. Obviously, the Python libraries that we've been using in the past are going to do this for us. Okay, they're going to do all the heavy lifting. And that's the great thing about this. So if I were to take this chart and expand it out and determine what all the Euclidean distances are, okay, then I can make this prediction. So if I look at this and I say, okay, here's my sample, I want to make the prediction, okay, and I know that I have my X and my Y, and in this case, you know, they're just inverse to what the chart says. And I say that my K, I'm going to select K, then you can really quickly see that my nearest neighbors are 1.4, 3, and 2. Okay, so this is how I'm actually able to determine what my classification is. And this tells me that it's going to be normal. Okay, so this is just simply how it's done. Very, very, very simple algorithm. Okay, probably one of the easiest ones out there for machine learning. So let's get away from the PowerPoint and let's head over to Anaconda and do this in a Jupyter notebook. So I've opened up a Jupyter notebook and I'm just calling it KNN. And the other thing that I have open is my dataset. So in this example, we're going to try to predict based on features whether somebody has diabetes. And I have this data set came right out of the Kaggle. It's one of the data sets. So it's called Diabetes 2. Okay, I recognize that this is slightly morbid, but it's an application in machine learning. Okay, so we've got pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, which is body mass index, diabetes, pedigree function, age, and outcomes. Okay, what are the outcomes for these people? So this is my sample data set. Okay, so, you know, this one is going to start off just like all of the other ones. And so to save a little bit of time, what I am going to do is copy and paste a few of these things. Okay, so I've clearly already worked out the code for this. So in some cases, to save time, I'll just copy paste. So in this particular case, we definitely need from our sklearn, we need to have our sklearn.model selection and then import train, test, and split. Okay, and then we have a couple other ones. These two new ones. These ones are new. We haven't done these before. So sklearn, and it's sklearn.preprocessing, and I'll hit the tab button and see if it comes up. And there it is, preprocessing. Okay, and sometimes you'll notice when I do the tab button, you'll see this little circle. Your kernel is working. And so if it stays dark, that means that it's actually looking. So it could take a second. You got to be patient with it sometimes. Okay, and then we're going to say preprocessing import, if I can spell it, import, and it's K neighbors classifier. Okay, so capital KN, hit the tab, and you can see it's not coming up because it doesn't have enough information to go on. So KN EI, and let's see if it comes up. Doesn't seem to be coming up right now. I'll just spell it BORS classifier. Okay, and hopefully that's spelled right. If not, we're going to find out with an error. So the next thing I want to add is from sklearn. In fact, I made a mistake, and this is good to have seen. Okay, so this one here, believe it or not, I'm going to rewrite this. So it'll be sklearn and preprocessing, and I don't actually want this KN or K neighbors classifier. The one I'm looking for was standard scalar. So standard, and you can see it popped up there. Okay, so in this case, the next one I want is neighbors. Okay, and if I start to do that, you can see that I can select neighbors and then import. So it's it's really important that from the right library, you're importing the right module. And you saw the example there. I was trying to get preprocessing to give me the KN neighbors, right? It doesn't match. There's no KN. So if you look, KN tab, it's right there. Okay, they have to match up, and I didn't match them up, and that's why I was getting the mistake. So then the next ones we need are ones that we've seen before. So I'm going to copy those in. Okay, and I'll just separate them out a little bit. You've got metrics with confusion matrix, F1 score, and accuracy score. Okay, so these are all things that we've seen. And I'm going to go ahead and run that just because I can. In this case, so I know that my data set, it's called diabetes 2. Okay, and the way I want to call in my diabetes 2 data set is same what we've always done. But in this case, I'm going to call it data set right here. Okay, so it's pd.read_csv dataset in single brackets, and we're going to do a print length and then a print head. Okay, so let's execute that right there and see what we get. Okay, so really what you're seeing is all of the columns that we showed before, and it just looks to me like, on the spreadsheet we can actually have it all in one row. But in this case, you're seeing that it's breaking the same row into two distinct rows on its own. Okay, so we're getting the right data set that we want. Okay, so the next thing is we're in a situation where if we look at the data itself, let me see if I can zoom that in a little bit more for you. Okay, if we look at this data itself, okay, there are certain points in this data that if they resulted in a 0, you probably would not be alive anymore. Okay, so the ones I can think of, if I look at glucose, if your glucose level was 0, I think you'd be gone. Okay, if your blood pressure was 0, you probably would be dead. If your skin thickness was 0, you'd be dead. If you had no body mass index, you would be probably dead. If you had no insulin, you'd probably be dead. Okay, so you get the point here. So what we need to do is to go into Anaconda or into our notebook here, and we have to account for this. And what we're going to say is, we'll start on the right hand side. And we're going to pick the ones that we want. Okay, so it should be single quotes, not double. So I want glucose. Okay, and I need to spell this the exact same way. So if I copy all of this, that's good. I'm going to comma. The next one I'm going to want in quotes. In fact, what I'll do is this. I'll copy all this and just paste it a few times. Okay, so I've got glucose for the first one. What about blood pressure? Okay, my blood pressure cannot be 0. Skin thickness cannot be 0. And what else cannot be 0? My body mass index cannot be 0. And I think finally my insulin cannot be 0. Okay. And so how do I go about doing this? So what I am going to do is I'm really transforming this so that I don't have a 0 number in here. Okay, so let's go and make this into something. So we'll say 0 not accepted. 0 not accepted. Okay, so the next thing I'm going to do now is a for loop. Okay, and I'll do it like this. So for column in 0 not accepted. Okay, and don't forget the colon there at the end. That helps with the formatting. I'm going to say dataset square brackets. Okay, column is going to be equal to data set, again, column, and I'm going to say replace. Okay, and this is just a function. Replace, and in my function, I'm going to say replace what? 0 with NaN, not a number. And it's N lowercase, capital N. Capital N, lowercase a, capital N. Okay, so that's the first part. Now, what's the mean? What's the mean going to be here? So int in here, what I'll say is data set column, dataset column dot mean, and this next thing is it's a pandas function or a pandas product. Skip NA, skip no number, okay? Or this, I'm referring to this NA up here, it's skip it. So you type in skip NA, and we set this to capital true. Okay, and that should be really it for that line. Now, we got to have a new data set column, right? Because we're processing this up above, and now we're going to say equals data set column, not the equals now, but dot replace numpy mp dot NaN and mean. Okay, so when I run this, what do you suppose is going to happen? Absolutely nothing. You're hopefully not going to get an error. I have to say, I really do appreciate that with these Jupyter notebooks, they are very good at pointing you in the errors that you're making. So this was supposed to be np.nan, and I did it previously. So if I run this, you can see nothing is actually happening right now. So the next thing I have to actually do is take my data set, and I'm going to split the data. Okay, this is all stuff that we've done before. Now, the way I want to split this data, okay, the first piece of this, okay, we know means look at all of the rows that we have. Okay, and this second piece, 0:8, is saying all of the columns from 0 to 8, but it actually does mean exclude the 8th. So what it will output is just from 0 to 7. Okay, it's really the outside boundary. Okay, so that's what we're going to do in this one here. So capital X dataset iLock like this. Okay, so for the next one, for our Y dataset, very similar, but we just want the answer in column 8. Okay, so notice that I'm not saying give it a range 0 to 8 and look at everything in between. I'm just saying I want to look, my data set, I want to be column 8, okay, which is outcome. So that's what my Y is going to be. Now this line here, this next line is something that we've done a number of times now. So it's X train, comma, X test, comma, Y train, Y test equals this train test split, which was where, you know, we're getting this, the module here from sklearn model selection. Okay, so it's train test fit, and we're saying X, Y, random state equals 0, and we're saying, you know, split it up 20/80. All right. So, you know, so far it's almost like we've literally done nothing different than sort of the other algorithms we've done in the past. Okay, so when I run this, does anything happen? No, nothing is happening right now. And so the next thing I want to do now is define the KNN, I guess the model. KNN. Okay, and I'll take this, I'm going to change this to a markdown, and I'll run that, and you can see it just puts the title in there. And what I want to do for this one is I want to create the actual classifier. All right, and so just really simply watch the code and see if you can figure out what I'm doing here. So if I say KN tab, K neighbors classifier, okay, take that, and it's a module, so it means it's a function inside the this right here inside our sklearn neighbors. Okay, that's where that's coming from. Now it takes a couple of parameters. So n underscore n, it's neighbors. Okay, so this is really our k value, and for this I'm choosing 11. Now key equals 2, and then our metric. Okay, so this metric equals Euclidean. Okay, so we have different options, but the one we're choosing, EU, okay, and it's not picking it up. It's not part of, like, it doesn't see it using the tab button for some reason. Okay, and so this is saying use k nearest neighbor classifier, use k as 11, and we're going to use the Euclidean algorithm within our KNN. Okay, so I hope that makes any sense. Now I've gone and I've run this, and you can see what this little output is. It's nothing. All it is doing is further saying, okay, we're doing Euclidean, and we're choosing 11 for our k value. Now I can't just kind of leave this one like this at this point. I actually have to assign it to something. And it helps when you spell things properly. Because now the next thing that I want to do is I need to fit the model. Okay, so we'll say fit model. Right, change that to a markdown, run this, and go to the next line. And now I want to say classifier dot fit. And in that fit function, I'm going to say X train, comma, Y train. All right, and so outside of this, what do we really have next? If I run this, I have an error. And the reason I had the error was because I didn't run this and then went to it. I kind of wrote the code in there, but I needed to run the classifier. Okay, so what's the next thing? And we're still really just kind of outputting, same idea, Euclidean with K of 11. Right, so the next step that we actually need to do now is do a prediction. And I'll change that to Markdown, do a run. And here it's just like we've always done. So classifier dot predict. And what are we predicting? Our X test. Okay, and let's put this into a variable. And we're going to just stick with what we've always kind of done. An underscore. Xpred equals. And then let's just output that ypred. And let's just have a look at this. Okay, so what we've done is we've actually predicted the outcome. Okay, so we've taken the 80% sample size and we've predicted what the future is going to be. And so one more thing that we need to really do with this, and this is where I want to evaluate what this is, because when I look at this, this is absolutely meaningless to me. Okay, so we need to evaluate the model. Okay, and how are we going to do this? Very simple. We've done it many times before. We're going to say CM equals confusion matrix. Okay, and confusion matrix is just going to be y underscore test, comma, y underscore predict. Okay, and then we're going to print CM. Okay, and let's have a look at what this says. All right, so we're getting this number 86, 21, 16, 31. What does this mean? Okay, what does this honestly mean? Let's look. Okay, because the way I see this as 86 and 31 are correct. Okay, and those diagonal numbers, this is the diagonal number here, 86 and 31. So those are correct predictions. Okay, where you see 16 and 21 are incorrect predictions. Okay, so that's the way that confusion matrix is actually running. So it's actually a column at the top a row heading and a column heading at the side. Okay, and so let's do our F1 score. Okay, and let's say print F1 score, and inside the F1 score we're going to have y test, comma, ypred. Okay, and what happens in this when we run it? Okay, we're getting a 62. Okay, and then the last one that I want to do is really just the most important one is look at the accuracy, because when we look at this accuracy, it's going to give us a better picture. So we're going to say print, because we've already called the library file. So if I say accuracy score, and inside these brackets, it's going to be test and pred again. Okay, so we'll just take this, copy, put it in here. And when we look at this and we run this, you can see that our actual prediction here is only 75.9% accurate. So let's say 76% accurate. So I would say that our model isn't that great. Okay, how would you like to be at a doctor's office and they say, hey, you have a 76% chance of having diabetes, which means in my mind, I would be hearing, I have a 24% chance that the guy sitting across from me with all the degrees on his wall is wrong. Okay, so this is why the accuracy score here is probably the most important value. Okay, we've talked about the confusion matrix in the past as well, but for this particular case, I think the best possible outcome is our accuracy score. So it's saying 76% that we're accurate. And I don't think it's going to change anything if I run it again from the very beginning. It shouldn't really change anything. I don't know if it will or not. Let's just keep scrolling down and see if it improves as we iterate. And you can see it's not really improving at all. Okay. So given this sample size, one of the things I can do is I can change my K value. So I set it to 13 and I went through and I got a marginal increase. Okay. Let's change this to 15. Okay. And see if that has any real significant impact. Okay. And I run through and, you know, my accuracy score actually decreased slightly. So, you know, it's good that we were able to evaluate the model, but I'm not really sure in this particular case that this is the best possible outcome. So let's just go through this one more time, and I've got some notes in here. So we've done all our imports at the very top. Okay, we've got our data set that we're taking inputs from, and we've looked at the length and everything. We're just basically outputting everything that's in our data set. We're going to 0 not accepted. We're saying glucose, blood pressure, skin, BMI, and insulin. Okay, and we're transforming this. Okay, so in here we're saying for column in 0 not accepted. Okay, we'll say data set column, and we're saying replace 0. Okay, with not a number. And then we're taking this mean and we're using from pandas, skip NA, setting that to true. Then our data set column equals data set column dot replace. Okay, and again, this is NumPy. Then we're splitting our data. Okay, and then we're doing this here. So with pandas, so I'm saying this means all the rows. Rows 0 to 8, but I'm only looking at 0 to 7, don't include 8. Here for my Y, I'm saying I just want to look at column 8, which is output. Then I'm saying X train, X test, Y train, Y test equals train test split, X, Y, random state equals 0, and our test size is 20%. Okay, I'm running that, and now I'm doing this. And to be perfectly honest with you, I'm wondering if I actually missed this step in my original example. And I do think that I missed it. So it's an important thing why I'm doing the review, because I know I wasn't getting the same output that I wanted before. And what do I do with the scalar? What is my scalar really meant to do? Okay, in my scalar, if you look at the range, okay, of the numbers in here. So you look at glucose as a good example. I've got 197 is a high value. I've got all the way down to 78. Okay, so my range is there's a 71. Okay, so my range is very broad. So the reason I did the scalar is to kind of bring that all within a relatively normalized value. Okay, and by doing the standard scaling, I could make all of this fit nice and neatly. So if you think back to when I had this as a graph, you know, something like this where it all neatly fits into a graph, it makes more sense. So I'm using these scalar functions here to put it all into a graph where the features will all fit nice and neatly. So it was the step that I missed when I ran the original. So make sure that you add in the scalar after you're doing your split data. Okay, and then again, after that, we're defining the model in KNN. We're calling it a classifier. We're using our K as 11. We're fitting the model. Okay, we have fit it now. And ignore this stuff here, but we're predicting our test results. And you can see the big difference because I didn't do the scalar when I went through this the first time when I showed this. Okay, you can see that my accuracy was greatly affected because as I go through this, I still do the confusion matrix. You see my numbers change. Okay, and 93 and 13 are correct. 94 to 13 are high risk with diabetes. 15 and 32 are wrong. Okay, and I'm just printing out the F1. Okay, and then finally, the most important thing to us right now is this is about an 82% chance. By doing that scalar, I increase the chances. Now, one thing I want to try and do, let's change this 11 to, let's say, 13 and see what happens. Does it increase or decrease our accuracy? Didn't really have any effect on the accuracy, to be perfectly honest. So it wasn't significant enough. All right. So take this, have a look, work this problem. And anyway, I'm going to leave it at there. It's a pretty light video for a change. And, you know, I hope you get out of this what I did. So anyway, I'll talk to you soon in the next video. Thank you.